All right, boys and girls, moms and dads, this is Teacher Chang, and we're going to go ahead and do a little review on conic sections. We're going to focus on circles, ellipse, and hyperbolas. So our circle, we want to go ahead and take a look at what that equation looks like. It has that format. The standard form of a circle has that format of x minus h squared plus y minus k squared is equal to r squared. Now we want to remember that the h and the k are going to be the center of our circle, where the r will be our radius. Okay, so that's our circle. Now for an ellipse, very similar to a circle, we now have a fraction. And the top portion looks just like a circle. It says the x minus h squared and the y minus k squared. But the bottom part, we have our a squared and our b squared. Now, a is always going to be the larger number because that's going to be our vertex. So anytime we have an a value, that's going to be our larger number. And if the a value is underneath the x, we have a horizontal ellipse. But if the a is underneath the y, and we have a vertical ellipse. So the a squared and the b squared can interchange. Whereas in a hyperbola, the equation looks very similar to an ellipse. If you compare the two, they look almost exactly the same. They have that x minus h squared, the y minus k squared. They have the a squared and the b squared underneath. They're both equal to 1. However, the biggest difference here is that instead of a plus sign, we have a minus sign. Now, I want you to also notice that the a values and the b values will remain where it is, except this time the x's and the y's switch. So we know that it's going to be a horizontal hyperbola if the x value comes first. So if the x value comes first, it's going to be horizontal. And if the y value comes first, then it's going to be a vertical hyperbola. So what we're going to do is we're going to go ahead and try out some problems, and we're going to see, well, which ones are vertical, which ones are horizontal, and we're going to determine whether or not it's a circle, ellipse, or a hyperbola. So let's go ahead and take a look at a few problems here. So this first one, we have y squared is equal to 25 minus x squared. And what we want to do is we want to go ahead and rewrite this equation in standard form. Now, to get this into standard form, we want the x values and the y values all on the left side of our equation. And that's something that if you didn't notice in our equations above, the x's and the y's were always on the left. So I'm going to move this x squared to the left by adding x squared on both sides. And when I add x squared on both sides, we now have x squared plus y squared is equal to 25. Now, this is actually going to be in the same format of x minus 0 squared plus y minus 0 squared is equal to 25. And now I could see that this is a circle. So my actual equation in standard form is this x squared plus y squared is equal to 25. I don't need those zeros. But those zeros tells me that these are my h and my k, which means it's going to be the center of our circle. So the center is located at the origin at 0, 0. So that's my h and my k value. Which means the radius is going to be that 25. So this 25 is my r squared. So if that's r squared, that means the radius is the square root of 25, which means the radius is going to be 5. And since the radius is 5, that means from the center, I'm going to go 5 units to the right, 5 units to the left, 5 units up, and 5 units down. And then we can go ahead and sketch out our circle the best that we can. So for me, the way that I sketch out my circle is I go ahead and focus on 1/4 of the circle at a time. Oh, that's not a very good part. So here's our circle. Not the greatest, but it's a sketch. It works out. All right, so let's go ahead and try another one here. We have our next problem. X squared is equal to 16 plus 4y squared. And again, the same thing that we did last time. We want to go ahead and move the x's and the y's all on the left. So I'm going to do the same thing here. I'm going to go ahead and get rid of that 4y squared. So I'm going to subtract 4y squared on both sides. Now the 4y squareds on the right will cancel each other out. And we now have x squared minus 4y squared is equal to 16. Now I already know it's not going to be a circle because a circle requires a plus sign and this has a minus sign. An ellipse also requires a plus sign, and again this is a minus sign. So this is a big clue telling me that it's going to be a hyperbola. Now a hyperbola must equal to 1, so what I need to do is I need to make this 16 a 1. And in order to make that 16 a 1, I have to divide by 16, because 16 divided by 16 is 1. Now, whatever I do on one side, I got to do to the other. And when I do it to the other, I got to do it to everybody to be fair. So I divide everybody by 16. And when I divide everybody by 16, my equation now looks like x squared over 16. And 4 over 16 is the same thing as 1/4, so y squared over 4 is now equal to 1. Now, same thing. We have our x minus h squared over 16 in this case, minus y minus k squared over 4 in this case is equal to 1, which means my center is going to be at 0, 0, because I don't have an h or a k value. So once again, I have my center being at 0, 0. Now, that a value, because it's a hyperbola, is always going to be the first one. So we know that the a value in this particular case is right over here. And that's a squared. So this is a squared, which means a must equal to, that's right, plus or minus 4. And that b has to be underneath the y. So I got to do the square root, because that's b squared, which means b is equal to plus or minus 2. So now I know what my a is and I know what my b is. I'm going to go ahead and figure out, well, what are these points? So when I take a look at these points, my a value is going to give me my vertices. And because the x value is first, because my x came first, I know that this is a horizontal hyperbola. So I'm going to go 4 to the right, 4 to the left, and these are my vertices. So if I had to write out the ordered pair of my vertices are located at negative 4, 0 and at 4, 0. You could also write it as plus or minus 4, comma 0. Now the b values will tell me my covertices. So my covertices we said was plus or minus 2. So from the center, I'm going to go up 2 and down 2. And that's going to give me my covertices. So the covertices are located at 0, 2 and at 0, negative 2. Okay, so now that I have my vertices and my covertices, what this is going to do, it's going to help me figure out where are my asymptotes, because hyperbolas will require some asymptotes here. So to do my asymptotes, I'm going to go ahead and draw a box. And this box is going to be a guide to help me draw my asymptotes. Now the box has to touch, the sides of the box must touch these vertices and these covertices. So I'm drawing a box so it touches my vertices and my covertices. It kind of connects all of them together. Now what we're going to do here is we're going to go ahead and draw a diagonal line connecting these corners. So I'm going to go ahead and draw a diagonal line here. And these diagonal lines will represent my asymptotes. Now, these lines go on forever, so we should put arrows on both sides, making them go in both directions forever, because our hyperbola will go on forever as well. Okay, so here I have technically enough information to draw my hyperbola. So I'm going to go ahead and sketch that out. Remember, we stated that it was a horizontal hyperbola because the x value came first. So I'm going to go ahead and draw that by starting at my vertices, and I'm just going to draw a parabola going towards the left and another parabola going towards the right. And when I have two parabolas going in opposite directions, those are going to be my that's going to be my hyperbola. So we have everything here. We have our equation. The equation, and I'll rewrite that equation. The equation that we have in standard form is our x squared over 16 minus y squared over 4 is equal to 1. That's our standard form. We have our vertices. We have our co-vertices. We have our center. The center we wrote down earlier was at 0, 0. I'll write that again over here. But we also need to look for a couple of focal points. Now, the plural for focal points is called the foci. So we want to go ahead and calculate the foci. Now, to calculate the foci, if you didn't notice from that formula, the formula page that I had up earlier, the foci follows that format of c squared is equal to a squared minus or plus b squared, because it's a hyperbola. So it has that Pythagorean relation, and in fact this is the Pythagorean theorem. So what we're going to do is I'm going to go ahead and take my a squared, which we already know they gave us that a squared with that 16. So the 16 right here is my a squared plus our b squared, which is 4, and that's going to equal to c squared. Well, 16 plus 4 is equal to 20. So if I want to go ahead and figure out what c is, well, I just got to square root it. So c is going to be the square root of 20, which is approximately plus or minus 4.5. Because 4 times 4 is 16, 5 times 5 is 25, and 20 is somewhere right in the middle. So so it's about in the middle, so about 4.5 in both directions. Now, it's 4.5 from the center. So from our center, I'm going to go 4.5 to the right, 4.5 to the left, and these are the two focal points, or the foci. So if I had to write out the ordered pairs for our foci, the ordered pairs would be at negative 4.5, comma 0, and at 4.5, comma 0. Okay, so that's a hyperbola. Let's take a look at another one. Okay, here we have something where the x and the y's are already on the left, and well, we know it's not a hyperbola because it doesn't have that minus sign. So it's either going to be a circle or an ellipse. Well, circles cannot have numbers in front of these x squares and y squares. In fact, we don't have that for any of our conic sections. So what we're going to do is we're going to try to get rid of those, and we're going to do that by getting rid of that 400 or changing that 400. Let's check to see if it's an ellipse first. And to check to see if it's an ellipse, well, I'm going to set it equal to 1. So I'm going to divide everything by 400. And when I divide everything by 400, I now have x squared over 25 plus y squared over 16 is now equal to 1. So I know that this is going to be an ellipse. If it was a circle, the denominators should be the same, but they're not. So we have an ellipse, and we know that because there's no h and k value again, we know that the center is going to be located at 0, 0. So I'll go ahead and plot that point right in the middle. Now with an ellipse, the a value is always going to be the larger number. So in this case, the larger number is the 25, which means this is our a squared and this is our b squared. So A must equal to plus or minus 5, and B must equal to plus or minus 4. Okay, so that means our A value, which is going to be our vertices, spelled that wrong. There's no I in here. Vertices. So if I were to look for my vertices, we have that plus or minus 5. I need to ask myself, okay, is this a horizontal or a vertical ellipse? Well, I check to see where that A value is under, and that A value is underneath that X. And because it's underneath the X, it's going to be horizontal. If the A value was underneath the Y, it would be a vertical. So since it's horizontal, I'm going to take my plus or minus 5 and go right 5 and left 5, and these are going to be my two vertices. So my vertices are at negative 5, 0, and 5, 0. Okay, that means the covertices is going to be coming from our B values, which means I'm going to go up 4 and down 4. And we can see that that's underneath the Y. So the B square is underneath the Y. So that means I'm going to go up and down. Again, technically I have enough information to draw my ellipse. So I'm just going to sketch this ellipse. It's not a perfect circle because, well, we got 5 left and right, and then we got 4 up and down. So not exactly the same. Okay, so there's my ellipse. Okay. All right. We have our vertices. I forgot to write down my covertices. I'll write that down now. So the covertices are going to be plus and minus 4 up and down. So that means it's going to be at 0, 4, and 0, negative 4. We have our center. We had our center earlier right over here. So I'll copy that down. Center is at 0, 0. And we have the equation, and again, I'll rewrite that equation in standard form. That was our x squared over 25 plus y squared over 16 is equal to 1. So that's our equation. And we also want to figure out where are my foci. So again, the foci has a Pythagorean relation. In the hyperbola, it was the Pythagorean theorem, a squared plus b squared. But now, it's going to be a squared minus b squared. Okay, so if I take a look what my a and my b are, well, my a squared is going to be our 25. And our b squared is our 16. And that's nice because, well, 25 minus 16 is 9. And in order to find out what c is just the square root of that. So that's going to be plus or minus 3. So what we're going to do is we're going to go ahead and go plus or minus 3 from the center. And remember, we have to follow the same major axis or the same line where it's with the center and the vertices. So I'm going to go plus or minus 3 to the right, plus or minus 3 to the left, and these are my two focal points. So there's my F1 and my F2. So the foci will be located at negative 3, 0, and at 3, 0. All right, let's take a look at a problem where this time we have a graph, but now we want to come up with the equation. So the nice thing about this is that we could see it's a hyperbola, and they gave us this rectangle. And the rectangle is there for a reason. It allows us to see two things. One, we need to figure out where that center is. So let's go ahead and find out where the center is. And the center is going to be, it looks like going left and right halfway through is going to be at 2. If I go ahead and pull this out, we can go ahead and see that the halfway point is at 2. And if we go ahead and go up and down between negative 2 and 4, it's going to be 3 units up and 3 units down from our center here. So here's the middle of our graph. Now, the center or the middle of our rectangle here. So the center is going to be at 2, 1. That's our h and our k value. The next thing that we need to know is that our vertices are going to be right over here. So our vertices are going to be located at these 2 points, and all we need is the distance from the center to one of our vertices, which means, and that's going to give us our A value. Now our A value is going to be 2. It's 2 units away from our center. The B value is going to be going to our covertices. Now the covertices is from our center to the top of our rectangle. So the distance from the center to the top of our rectangle is 3 units. So B is equal to 3. So let's write all that down over here. So we got our center at 2, 1. That's our H and our K. We have our A value at 2. We have our B value at 3. Now we said earlier that this is going to be a hyperbola. And we know that it's a horizontal hyperbola just by looking at the direction that it's opening. And since it's a horizontal hyperbola, we know that the equation is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So all I got to do is plug in my information. So I go ahead and plug and play. I'm going to go ahead and substitute what we know here. We got x minus h, well h is 2, squared over a squared, well a is 2, so 2 squared is 4, minus y minus k, and k is 1, squared over b squared, and b is 3, so that means 9, and all of this is equal to 1. And here's our equation. All right, I got one more problem for you, and this time it's a little bit different. Here we don't have a graph. We don't, they only gave us the foci. They gave us the vertices. And what we want to do is we want to come up with the equation of something that looks like this. Now, to figure this out, we need to figure out, well, what's our center? And to figure out our center, we need to take a look at our information and ask ourselves, okay, is this going to be a horizontal or a vertical ellipse? They told us it's an ellipse. So it says, write the equation of the ellipse. So we already know it's an ellipse. The question is it a horizontal or a vertical? Now, what I noticed is that the x values stayed the same. So our foci and our vertices, we know that they have to be on the same axis. And since the x values are the same and the y values are changing here, so we can see that the y values are different, well, that means it has to be a vertical ellipse. So if you need to, you can go ahead and sketch it out if you want, if you're more of a visual person. So if we actually sketch this out, if we drew an axis here, and we can see at this point, let's say that this is where we have our 2 vertices, and our 2 vertices are located at 4, 2, and we have another one located at 4, negative 8. And then somewhere, since this is all the same x value, oh, I'm sorry, this is horizontal. I drew it horizontally. They have the same x value. That means our axis is going to be vertical. So if I go ahead and redo this, so our x-axis is going to, or our x values are going to be the same, which means I'm just going to draw a straight line up and down because we have a point. Let's say this is at 4. So we got 4, 2 at the top. And the y value for the other vertex is 4, negative 8. So that means it's going to go down 8. And then we have our foci somewhere at 4, 1. So let's say that that's 4, 1. And then we have another one right here at 4, -7. So they all have the same x value, so they have to be on that same point in terms of our x and our y axis. All right, so it's a vertical ellipse. We want to figure out what is that center. Well, that center is right in the middle. So really what we want to do is we want to average out our y values. We know that the x value will still be 4. We just need to figure out, well, what is that y value? So the easiest way is to just average out the y values for your vertices or average out the y values for your foci. So if I actually did my vertices, the vertices we have at 4, 2, and 4, -8. Well, 2 plus -8 is -6. Divide that by 2 and we get -3. So we're just averaging out the y values to get our center. So now we know that the center is located at 4, -3. We want to find out that point in the middle. Okay, so we found out our center. We now need to figure out, okay, well, what is the distance of our a value here? So our a value is going to be the distance from our center to one of our vertices. So the distance from our -3 to 2 is going to be 5 units away. So a is equal to 5. Now the foci is our c value. And that's the distance from our center to one of our focal points. So if I go ahead and find out, well, what is the distance from -3 to 1, well, that's 4. So b is going to equal to 4. Well, I'm sorry, not b. C is equal to 4. What we don't know is b. Since this is a vertical ellipse, we know that the equation should have that format of x minus h squared over b squared plus y minus k squared over a squared, and all of that's equal to 1. So we just need to figure out, well, what is that b value? So I'm going to use our Pythagorean relation, which is c squared is equal to a squared minus b squared when it comes to an ellipse. So we already stated that a is equal to 5. So 5 squared is 25. B is unknown. And c is 4, so 4 squared is 16. So we just need to go ahead and do the math here. I subtract 25 on both sides. The 25s will cancel each other out, leaving us with -9 is now equal to b squared, or negative b squared. We could divide by -1, or we could just cancel out the ones, or the negative ones, and make this a 9 is equal to b squared. And that means we just need to square root them, so c is equal to 3, or b is equal to 3. I'm messing up here. All right, so b is equal to 3. So now that I know what b is, I know what a is, and I have my center, I can write out my equation. So my equation is going to be, and I'm just going to plug and play, x minus h, well, h is our 4, so x minus 4, over b squared, so b is 3, so that means 9, plus y minus k, and k is -3, so that means plus 3 squared, over a squared, a is 5, so that's 25, and all of this is equal to 1. So our equation is going to equal to x minus 4 squared over 9 plus y plus 3 squared over 25 is equal to 1.